Hello everyone, welcome back to the channel. Today we will be solving what is the largest element in the array. Here you can see that an array is given which has 1, 8, 7, 56 and 90, and what is the maximum of them? It is 90. Okay, and here 5, 5, 5, 5, and the maximum element among all of them is 5. And here we have array is 10, output is 10. Okay, today we will be seeing about the brute force and the uh, optimized time complexity algorithm. Let me show you with the help of an example. We'll be taking this example: 187, 56, and 90. Suppose this is an array, okay, and we have 1, 8, 7, 56, and 90. Okay. First, we will be discussing about the brute force approach. Brute force. So, as you know that every algorithm has its own sorting algorithm. So in Java we have something called as arrays.sort. Okay, where we can pass the sorting array sorted where we can pass directly the array and it will sort it. So after sorting, you can means it will basically sort it in the ascending order. Okay, let me show you. This is not the right example to show the sorting. Let me show you with the help of a right example. Suppose you had 0 uh, minus, suppose you had 0 minus 1, 3, 2, 8, and 7. Okay, now you can't tell what is the sorting algorithm. Like you can't just directly tell what is the biggest element along all of them. You can watch it, I know, but you can't anyway find an algorithm just to tell it that what is the sorting. So the thing is that the brute force approach says that we will first sort the algorithm, and then what is the last value will be your largest element in all of the array. Because what arrays.sort does, it will sort the entire array into an ascending order. Okay, it will sort it into an increasing order. Okay, so suppose this is an ARR array. Okay, so what I can do is first I will do arrays dot sort, and I will pass the array into it. And so after sorting, what it will be minus 1, 0, 2, 3, 7, 8. Okay, after sorting, this will be the entire array. Okay, so what is the maximum all of them? This one, right? This is the maximum. 8 is the maximum out of all the array, so 8 is the answer. Okay, so I will write the code also for this. You can try it by yourself. Suppose the input array is given ARR, you will just write arrays dot sort. Okay, arrays dot sort, you will pass the array, and what you will do to find the last element of the array. Okay, you have to basically the answer will be the last element of the array because the array got already sorted in this exact line. Okay, so how do we find the last element of the array? Sorry about that. So how do we find the last element of the array? Suppose here the array's length is what? 0, 1, 2, 3, 4, 5. Okay, so as you know that array is based in the zero based indexing, so it is 6 length of the array, because 5 plus 1 is 6 if you go from 1, 2, 3, 4, 5, 6. Okay, so what it will be? ARR of what? ARR of what? the last element. So how do we get the last element? ARR dot length. Okay, ARR dot length will give you what? 6. 1 2 3 4 5 6. ARR dot length will give you 6, and out of that, where is the value? This one. So ARR dot length minus 1, because this value is at the fifth index. Okay, so what we will do, we will just write here ARR dot length minus 1. Okay, this is the answer. Okay, so as I said you that this is the brute force approach. Okay, because this sorting algorithm is taking a time complexity of big O of n log n. Okay, and it will take a space complexity of big O of 1 itself. Okay, so no need to worry about this space complexity, because big O of 1 is, like it doesn't even matter how much it's like a garbage value kind of thing, but it doesn't even matter because we are not even using an extra space and all. So this will work. I'm not saying this will not. Let me show you how it is gonna work. In here I can just directly do arrays dot sort, and I will pass the ARR in here. Okay, so what it is saying that we have to return an integer array, right? I can just write in integer answer equals to ARR of ARR dot length minus 1. That's it, and I can just return the answer. That's it. That is the entire thing. Let me just check it. The answer, expected output 90. It will get submitted as well. So this is having an big of n log n time complexity. Okay, so I will now show you what is the most optimized approach of this algorithm. It will work. This is very fine to do it in competitive programming and all. Now let me show you one more approach of this. So make sure that this is n log n. Okay, now let me show you an optimized approach. I have the same array. Okay, let me just take it the same array. Sorry, I don't know how to draw this. Okay, minus 1 0 sorry, minus 0 0 minus 1 3 2 8 7. Okay, minus 1 sorry 0 minus 1 3 2 8 7. Okay, so this is the entire array we are having right now. Okay, so now see, I will take my I pointer at here. Okay, right at here I will take a I pointer. I will go entirely through the loop. Okay, I will use a for loop for this. Okay, my first I pointer will be in here. Okay, I will take a max variable. Okay, I will assign it to what? 0. You can assign it to integer dot min value also, like minus something, minus 0 1 2. I think integer dot min value comes around minus 2468, something like that. I don't remember, but it is exactly like that. Or you can take directly max, assign max, you will assign max ARR of 0. Okay, this is done. Means what is the max holding now? 0. 0 value max is holding now. Okay, now we will use a for loop. Okay, for int whatever, you can go for I to less than ARR dot length. Okay, what is here? 0. Okay, now what you will do, you will check if, okay, ARR of I, wait, let me not do the code first, let me just show you with the help of an example only. Okay, wait. In here, what I told you is that in the first value we are storing the first value, right? So max is holding now 0. Okay, so we will go through the loop. Okay, now then we will compare, is the maximum value currently greater than 0? No, so max stays the same. Okay, max equal to 0 only. Then this is I equals to 0th iteration. Okay, then we will go to the next iteration. If max value is greater than minus 1, no, so Still max stays the same. Then we will go to the third iteration. I equals to 2. Max value is greater than 3. Is is what is the max value right now? 0. Is max 0 greater than 3? No. No. Sorry, 1 second. I think I did the wrong thing. 1 second, 1 second, 1 second. I'm very much new to this teaching thing, so please bear with me. I will make you understand, don't worry. First we had here, okay, at 0. In the I equal to 0th iteration, what we will do is, if the is the max value less than, okay, less than what? 0. You can do equal to also, it doesn't matter. Less than equal to 0. Yes, so max value is 0 itself, okay. In the next iteration, is the max value less than or equals to, after this I will be transferred to here, okay. Is the max value less than what? -1? No. So the max stays 0 itself. Then in the next iteration, is the max value less than equals to 3? What is max? 0. Here is 3. Is 0 less than equals to 3? Yes. So what will be the new max? It is 3. So we will update this, put 3 in here. Okay, it is in here. Okay, so we currently have the max value as 3, right? So after that, I will be pointing in here. Okay, I equals to 3 is the max value less than equals to 2, because what is here? 2. What is the maximum value? 3. Is 3 less than equals to 2? No. So max stays 3 itself. Okay, in the next value I equals to 4. Is the max value less than equals to, after this it will come in here, is the max value less than equals to 3? Sorry, is the max value less than equals to, what is in here? 8. Is the max value less than equals to 8? 3 is less than equals to 8? Yes. So max gets updated to 8. We will cut it from here and put it at 8 in here. Okay. In the next iteration, I equals to 5. Is the max value less than equals to, what is it? What is the maximum value right now we are having? It is 8. What is the next value we are having? It is 7. Is the max value less than equals to 7? No, because 8 is here. This is 7. So we will update max equals to 8. It will stay the same. We loop through the entire loop and we found the maximum value to be 8 itself. Okay. Generally what I am doing is, this is the entire, to be honest, this is the entire 1 2 3 4 5. Okay, the main thing in here is that I'm going first in here, checking, assigning it to the max value. Next time going in here, checking if this value is smaller than this value, updating the max. Then going here, if this value is smaller than this value, updating the max. And going here, if this value is smaller than this value, then updating the max. Same, this value, then going here, if this value is smaller than this value, then updating the max. So the maximum comes at 5. That's it. This is, okay, wait. So I could have done this as well. Okay. So this is the largest element, how to find the largest element in the array. Okay, this will work in both sorted and unsorted array. Now why I was saying that this is the optimized approach and this approach is because in the previous approach in the previous approach, what was the time complexity that we were getting? It is big of n log n. Okay, and this approach, we are just iterating through the array. We are not taking any kind of any other algorithm, something like that. So what is the time complexity? It is big of n. Okay, and both will have the space complexity of bigger one itself. Both will have the space complexity of bigger one. Yeah, because they both are the same only. Okay, neither we are taking here any other space, neither here, so they will have the same time complexity. Let me show you how it will work in the form of code. I will just reset this. Okay, first what I told that first we were updating the array to the first element. Okay, so I am just taking it int max equals to arr of 0. I just took arr of 0 as my first element. Okay, then I will iterate through the loop for int I equals to 1, because there is no point of checking, like near there is no point of checking the first value with the first value itself. Okay, there is no really point. You can you can also do this, you can also do that, this 0 as well, but it will save just one iteration. Okay, nothing else. Okay, for int I equals to 1, I less than arr dot length minus 1 I plus plus I plus plus. Okay, then what I will do is if max, here I have taken max. Okay, if max is less than or equals to arr of I. Okay, what I will do is I will update max equals to arr of I. Okay, that's it. I will update if the maximum element is smaller than this elements, as I showed you here. If this, when I was in 1, what is in 1? Minus 1 is minus 1. Is 0 less than minus 1? I told no, so max stayed as 0 only. Okay, so similarly maximum is in arr of I. So after this exact iteration we can just return the maximum value and return max. That's it. That's the entire iteration code. Let us just see if it works. What is this? Your output is 56, expected output is 90. Okay, this is not supposed to happen. Int max equals to arr of 0 for int I equals to 1, I less than arr dot length. Yeah, if max less than or equals to arr of I. Okay, though for int I equals to 1, I less than arr dot length minus 1 I plus plus. If maximum element is less than arr of I, then max equals to arr of I. Okay, so 1 second, let me just check what is the answer in here. Maximum equals to arr of I. I am going through the entire array. Okay, I think here it will be equals to, because what I am doing here is that I am going through the entire array. Okay, max dot length, my array dot length minus 1 means I'm going till year 8. I'm not even checking the 7. That is the reason it didn't go till 90, and it printed 56. That's it. This was the issue. Sorry, it's an issue from my end. Sorry for that. Okay, you might think that what if if I do minus 1, why it will not work? Yeah, it will work if you put an equals to in here. That's it, nothing else. Nothing else. That's it. All right, thank you for joining. See you in the next video.